Well, greetings, good people of the World Wide Web. Welcome to lesson 9 of Golang for absolute beginners. Today, we will be making our game unique candlestick playable. Last week's challenge was to present the user with the 3 cards in their hand and ask them to choose which card from the Asker library we created before. There are actually 2 ways of doing this, and I think they're about equally good, so I'll just do one of them. After that, we should be able to make a 1-player game work by the end of today. I don't think there's going to be a whole lot of new concepts in this, but we'll see. But this should lead to us to a place where next week we can do some interesting stuff with a bit of a web server. Once this game is working, we'll be able to make it so it's a bit more shiny online-y. If you have fun with all of this, don't forget to like and subscribe, and let's get on with it, shall we? Where were we? So candlestick.go is this one here, and our tab. The function I asked you to make was going to be ask for a card, right? And it's going to take a list of cards. So I guess a sensible name for this function would be askedcard. Yeah, func askedcard, and this takes a slice of int. Our cards are a list of cards. And actually this is pretty straightforward, so we will quickly call ask. Have we imported Asker? I don't think we've imported Asker, so quickly we import. Now on my computer it's stored in mylib. Is that what I called it? Quick cd scripts go source. Yeah, mylib, no capital. Mylib stroke Asker. You could have put it anywhere, of course. That's where I put it, so that's my library. Now we've got that, I can asker.askInt on, and a message I'm going to ask is please choose a card from, and then I'm going to put this in really lazily for now. I get confused about the font things, the font options. It's been a while. I think V works here, and then that was silly. Let's call it cards, and and this is me being silly. Of course that wouldn't work. I thought I could be really lazy and use thump to put those together, but I don't think I can. I wonder if I can just put string around it. It's always fun to just try something lazy, see if it works. Have I got a missing bracket? Oh, there should be a plus here. You want to concatenate those two. So if you a plus with strings just sticks one on the end of the last one. So in theory, this should call the asking library to ask a card from this thing. The problem is they may not get the right response. So we're going to need a loop for a colon equals, so that's our answer, a for answer, colon equals if Oh, we've already written a contains, haven't we? So contains cards A. Then we can return. Return A. Otherwise, print line stick to the list, please. That'll probably do the job. This is tricky to test. The problem with the testing library is it doesn't give you good access. You can't. You don't get to play with standard out, and the whole thing about Asker is it needs standard. It's working with standard out and standard in. So either I need to break that apart and stop forcing it to use standard in, or I just. But the only place it makes sense is standard in. So let's come down here and what have we got here? This just prints out the players, so we can actually forget that and just have a quick ask card, and this will take an int, and these will be 4, 6, and 7. So we need to try all of those, and I colon equals, can't use I here, C, we probably could use I actually, but I won't. C, and then I'm also going to hide the actual printing of the cards in the deck for now. It's not something we want anyway. Bumped dot print line you chose, and then C. Let's see what happens if I do it. CD candlestick. I'm going to make this a slightly tidier width so the dollar's in the right. If I just run it over the line, then I get to see it slightly better. Here we go. So, so go run candlestick dot go, and we've got some errors. Good. Candlestick go 35 cannot convert cards type int to a type string. That's not actually a big surprise. Had this vague hope that it had a string method that would just work on it. We can try that. See if it works. Askedcard. There is in Golang this thing called an interface, and lots of things implement it. No. This is not a slice is not a stringer. That's okay. I think we need to make our string of cards here. So mess colon equals please choose a card from then for underscore comma v in range cards mess plus equals, so plus equals here is basically concatenate to this, so it's the same as equals mess plus, it's just a nice shorthand. Plus equals string v plus quote comma space. And I'm going to add a space here as well. And then in here, that's better, mess. Candlestick go line 40. Non-bool contains, let's go to the right line and see. Colon 40. Oh, yeah, that's right. Is greater than, no, is greater than or equal to 0. Line 41, too many arguments to return, because askedcard doesn't return anything yet. It does actually, it returns an int. It should do. 148. I think we're okay, that might fix that problem too. Please choose a card from that's not what I expected. That's funny. Of course, we need to use string convert. So, something very interesting that you might want to know, an integer is just treated as that character. So it's returned the Unicode character number 4, which doesn't actually have any value. The character 7 apparently is a blank character, but if it doesn't know the symbol to use for that character, then it just puts... Good, that makes sense of that. So let's get rid of this. String convert dot, and it's I to A. Should fix that problem. Have we not got string convert? Did I just call it the wrong thing? Okay. Import string convert. It's actually not that big a surprise that I haven't got string convert here. Please choose a card from 4, 6, or 7. If I say 5, it says, you chooses 5. I didn't say 5. Let's try this again. Go in candlestick go. If I say 4, you chooses 4. So I have made a mistake. Askedcard. Oh, it contains returns the number it contains. It doesn't get an index. So if I say 5 now, no, please stick to the list. 4, 6, or 7. Okay, so there we go. We have our asker thing. That was the challenge. So the next thing we wanted to do was to have a round function. So let's start here. Someone is doing some pretty heavy hammering downstairs. I don't know how long that's going to last. Funk. And we'll call this round. So we'll play a single round, and it's going to take a slice of players, and of course you need to give those a name. PL, that'll do. And it's going to take an int for whose turn it is first. I don't think it needs to return anything because it's going to edit the slice. We'll see. It might need to return something later. Whenever it is done slamming doors downstairs, I shall try and carry on with this. Main seed. So obviously we play a round. the first thing it needs to do is go through the list of players and ask them each for a card. So, but the thing is, it can't just start with the first player, which is like the easy way to do this. It doesn't quite work for P, comma K, comma P, colon equals range PL. But this doesn't really work if you need to start halfway through the loop. So what I'm going to have is a for loop, pnum colon equals first. Then we need another complete variable, complete colon equals false. And for we'll call this continue. No, we'll do it like this way. For not complete. Okay. And so what we need to do is we need to start with the first number. We can't just check if it's below. When we do normal loops, when we're just going from somewhere at the beginning to somewhere at the end of our list, we can just go as long as we're lower than the beginning, that's fine. Here we've got slightly different challenges. We're going to start, we could start anywhere in that list. We could start with player 0, or we could start with player 5, and then have to go all the way around to player 10, and then back to 1 again. So we can't just check that it's below the number. We need to only break when adding puts us on the thing. So at the end we'll do this. Pnum pnum equals pnum plus 1, and then we're going to use the fancy keyword, well, the fancy function called mod, which is the remainder. If you do a division like 7 mod 5 is 7 divided by 5, and you take the remainder is 2. But if you did 12 mod 5, the remainder would also be 2. Because 12 divided by 5 is 2, and that takes away 10 of it, and the 2 is what's left over. So that's what mod does here. Mod len PL. And because mod probably happens first, we're going to put brackets around that to make sure we add the 1 and then we take that mod. So the theory is that as soon as it gets to however many players there are, we've been working on the idea there are going to be 4 players, but this game works just as well with 8 or 10 players. So however many players there are, we loop, and then if pnum equals first, then complete equals true. And that's how we break out of the loop in this case. The other option is, of course, to break. I don't like using breaks. This is a personal preference. A lot of other programmers use breaks fine. I find I don't trust where they're going. So if I can put it in a separate function, that's often happier for me as well. We're going to need an array of chosen cards. Chosens, and that's a slice of int. And we're actually going to make one that is the right length here. Make a slice of int, and this will be the length we want, and that will be length of players of PL, right? So the chosen cards come from here, and then chosens at pnum equals, I think, pl pnum dot choose card. And I'm sure you're wondering, if you've been watching this with me from the beginning, where on earth does choose card come from? That's a very good question. It doesn't yet exist. But by writing this, now I know that I'm going to need to have that function to choose the card. We could use askedcard, but we don't know how many players, like, we can't use askedcard for every single player. So we're going to make a little function that belongs again to that type, the type player. So I'll put it here as well. Func self, and that's a pointer to a player. And that is choose card. So, and that doesn't take any parameters, but it returns the card that's chosen. Now, my theory here is that it will choose the card, it will actually take it out of his hand, so this will do the damage, I guess. It does reveal a mistake I've made elsewhere. I've forgot that I'm supposed to be working with a set of pointers, so I'll fix that in a minute. Choose card. Now there are two things. Some of these players will be human and some of them will be computer players. And I don't necessarily know which ones will be which. So I'm going to add a thing in here which says is human. And that's Boolean, i.e. yes or no. So chosen colon equals 0. No, I'll call that chosen lock. We'll call it lock, actually. Lock, short for location. So if self dot is human, then there's a couple of things we're going to need to change here. This is a big one. New player. If it's a human, is human. And that's bool. And that will cause some little wobblies. Somewhere else in the code, wherever I make the humans, the cards, but that's fine. So if it's human, we're going to use, if it's a computer player, we're just going to take the first card in the deck. Otherwise, we want to take so a colon equals askedcard, and now it's self dot hand. Now, did I make those caps or lowercase? It's all lowercase. So self dot hand. That should actually get us the card, but that's not the same as the location of the card. A colon equals, we'll get rid of the colon here actually. The colon equals creates the first instance of the variable by not putting a colon. We say we're using the one that already exists. A colon equals. That's a very good question. Self dot hand 0. And this will become, it's the opposite way around of doing it. Index. How do we do index? Let's forget about lock. So we've got a player. Self dot hand. So we've got a new hand we're going to make here. So h2 colon equals new make self make a slice of ints. Wrong way around. It's for underscore comma v, because again I don't need, and that's in the range of self dot hand h2 equals h2 dot if v does not equal a. Append h2 and a. No, v. And then we draw a card, self dot draw cards, only one, and then we return A, the card that was chosen. That may not be pretty, but we can actually do a little quick loop in the main to see if it's working. This is a pain, because it's using human input, it's really difficult to test. But new player, I equals 0. So that's a Boolean statement that will return true if I is 0. So only player 0 will be human, the rest will be computers. For yeah, we can use I again. Colon equals 0. I is less than 13. I plus plus. Funct dot print line players nor dot hand. And then C colon equals players nor dot choose card. And then we'll do that. And in theory, let's get rid of that S, that was never supposed to be there. In theory, this should run us through a deck of 3 cards. No. A deck of 13 cards. Undefined players, 159. $159. Oh, that was another mistake. Because I needed that to take a slice of pointer to player. I think that should actually cover most of that. Lock declared and not used in 60. 60. Please choose from 10, 4 or 1. So if I put 1, please choose a card from 10, 4, 1 or 8. So it successfully drawn a card, but it forgot to get rid of that card. 5. No, stick to list. I do 1, it's... So it's drawing the cards though, isn't it? It's just not getting rid of the cards. That's fine. Let's that means I can probably just do this. And then it panicked because the slice was out of the bound range. That makes sense. I did wonder about that. I had this vague hope that this would just work if you try to draw cards more than were in your hand. Here we go. Here was my mistake. Self.hand equals H2. Okay, so if I now choose 5, now we have 2, 12 and 11, that's correct. If I choose 11, we have 2, 12 and 13. If I take 2, we now have 12, 13 and 7. So this is correct. Basically, I'm choosing one of the cards in my hand. It's noting which card has been chosen. And then going through, and the main deck is going down. There comes a point where I can't draw a card, and this is panicking. What I think I'm going to do is I'm going to make this return a boolean. Len self.deck is equal to 0, then we return false. And down here we return true. So this will basically say it won't try and draw a card if there are no cards to draw. And just by doing this, we should find that this is safe for now. So if I 9, 8, 10, 6, 13, 12, 1, 11, 4, 3, 2. There we go. So it's 7, 5, and it finished. So now we've chosen all of our cards, and the computer can choose them randomly. I'm pretty sure that that will work. That can be tested actually because it doesn't need human input. Right now though, I'd rather get something showable. So instead, there are 13 rounds to the game. Round players, obviously. And for who's go first, we'll put I mod 4, right? There's 4 players. So for our lazy version of the game, that should work. So the modulus again is the remainder. So if I is 7, then it will be player 3's turn. Player 4's turn, because 0 to 4. The players are 0 to 3. So player 3's turn if you count 0. Next question. We've chosen the cards. We got as far as choose cards, but we never actually got as far as doing anything with that. So at this point, everyone chooses their cards. Actually, let's output something to the screen as well here. So p thump dot print there. And this will be P %D, so whatever player number, colon, space, and then another %D, which is the card they chose, and then a new line, and then close the quote. And so the two numbers are, I guess, pnum and chosen. Pnum, close brackets, and well, let's see what we get. Go around, please choose a card from 9 to 10. I'm going to choose card 9. So I chose 9, they chose, player 1 chose 1, 11, 1, and player 1 chose 11, then 2. So they've all chosen their cards, and now it's my turn to choose a card. And yeah, that kind of works. Okay, I'll quit that there, Control C to quit. And the next thing to do is, of course, to work out who wins. Winner, colon, equals, decide, trick, and then just chosens, I think. But decide trick actually returns 2 things. It returns a winner and a card. Decide trick. We did this. Decide trick returns winning player, winning card. Yeah. And so we were in round thump dot print line thump.println 1 player %D wins with %D and a new line, and then not too hard here. What are we putting out? Win P, win C. Something's missing. That should fix that. Choose a card from 2, 6, or 7. So I'm going first the first round. I'm going to choose card 7. Did I put print line? That's silly. So the mistake here was I put print line, not print f, so the %d's got read as %d, not as what they're supposed to be. That's in round again. Oops. Whatever I just did then. Round. Okay, let's try that again. So, 7. Player 1 wins with card 13. That's the king. Yeah, that may... Oh yeah, the 7 and the 8 cancel each other out. Player 1 wins. Happy with that. So, now I'm going last. 9, 4 and 2. Nothing funny going on there. I win if I play with card 10, right? Player 0 wins with 10. Yep. Player 2 and player 3 have played already. So the only thing it's not doing now is keeping track of the score and moving to the correct player at the right time. Let's get it keeping track of the score. Yeah, we'll have a scores message. Scores mess colon equals quote scores colon for underscore comma v in the range of PL scores mess plus equals string convert dot I to a of, so that's just turning it to a string from a number value. No, value dot score, and we'll add a space to that on the end as well so that we can separate them. $180. What line am I on right now? 180. Oh. Keyword missing. Range. Okay, so let's give this a go. So, I've got 5, 6 and 10. I'm going to put 10 because it's my highest card. Player 3 wins with the card 1 because player 2 played card 13. But it's not printed scores. Ah! Of course it hasn't. I didn't tell it to. Print line scores mess. Try that again. This is just my spelling. This keyboard is bigger than my keyboard and I keep mistyping. 13. And the scores won't change because I never told them to. But it's going to print the scores out nicely. So why didn't I tell it to change the scores? Well, when we work out who wins, we then go win p dot score plus plus. Okay. So 8, if we choose card 8, player 3 won that because they played 2 and I played the 8, which meant the lowest card wins. Yeah, that makes sense. 3, 11 and 8, so lowest card wins. I don't have a lower card, so I'm just going to play my 9 because that's a middling card. Get rid of it. Please choose a card from so player 2 and player 3 have already played 4 and 6. I reckon my best odds are playing the 12 here actually. I won, yes, I got a point. Currently though, player 0 is winning because they have a unique score. Player 1. Player 3 has played 1. I've got 5, 13 and 2. So I can't play 13 to win this. I probably should have played the 13 last round, actually, because it's more useful to... Never mind, I'll play the 5. Player 1 won that. And now I'm just starting from the beginning, so play an 11. And this is working. I'm very happy with how this has come out. I'm going to leave it here. If you want a challenge for next week, try and change it so that the player who won the last round gets to start the next round. And if you want a bonus challenge, I think you can do this. I think we've gone through enough. Your next challenge will be to make it so that the player with the highest unique score after 13 rounds is declared the winner by the program. So it will say, player, this thing wins the whole game. And that's everything I want you to do. So have fun with that and catch you sometime soon. Bye for now.